Alright, so we got into rapid prototyping processes and operations for your chapter 20. So rapid prototyping, alright, so this technology continues to grow, of course you know it, into a unique manufacturing discipline. Yeah. This is a physical model producing technology. So what we do by using this technology is we're just making model, right? Model, physical model, like this. And of course, in rapid prototyping, we use, we use it to identify, right, design errors. We use it to correct design errors, right? Because we're making a physical model, so you can be able to see these errors, right, in your design. We also have several techniques, alright, developed in rapid prototyping for producing parts, right? And that means like we can be able to do direct manufacturing of parts by using this modeling technology. So it's getting better. Okay, so for fused deposition modeling, well, this method we need a computer controlled extruder and through which a polymer filament is deposited, and we produce that part slice by slice. Okay, so the most important thing right here is for this type of modeling, you're going to use a computer control extruder, and then the production is going slice, right, by slice. Stereolithography, we use a computer control system, and of course we use a laser, right, beam to cure a liquid thermosetting polymer. This is just a plastic that we print the model, and you can call it resin as well, liquid resin. And this liquid contains a curing agent, and we call it a photosensitive curing agent. It comes in many different brands. Jet and polyjet modeling, we use inkjet printer heads to eject the plastic or photopolymers to build prototypes. So for laminated object manufacturing, here we use a laser beam, okay? Or we use a vinyl cutter to first cut the slices on paper or plastic sheets. And then we're going to apply an adhesive layer if it is necessary. And then finally, we're going to stack the sheets to produce that part. We all know 3D printing, so this is just your three-dimensional printing. Of course, we're going to use this inkjet mechanism, the same thing. You deposit the liquid droplets, that's your plastic, to the polymer, okay? Sometimes you use metal, or sometimes you can use ceramic powders. Depends on your 3D printer. So by using multiple print heads, 3D printing, you can also produce full color prototypes. Alright, the next one is a ballistic particle manufacturing. But for this process, we directly deposit the built material, and that's pretty much similar to your 3D printing. Alright, so selective laser sintering. Here we use a high-powered laser beam, meaning like strong, yeah, to sinter the powders or coatings on powders in a desired pattern. So basically, we're using the laser to make patterns, okay? And this has been applied to polymers, sand, and ceramics and metals, okay? Okay, so the next one is your electron beam melting. So here it uses the power of electron beam, of course. And so what do we use this beam for is we use it to melt powders and also form fully dense functional parts. Okay. So in electron beam melting, you use this beam, you know, and you're gonna melt the powder, and then you're gonna form right into functional parts. Okay, so rapid prototyping, they really have major effect on manufacturing processes because the development time, product development time, is now shorter. Okay, meaning like these techniques have made much faster product development times. So rapid prototyping can produce blanks, especially for investment casting or similar processes. We can produce metallic parts quickly, inexpensively, okay, even if you want to print just one part. So this is a very convenient, right, machinery. So rapid prototyping technologies, we're now using them in injection moldings and in shell mold casting. We use them in forging. It's very good because we can reduce the lead time between design and manufacture significantly. Okay, so I'm going to go ahead and stop right here.